Today I'm going to be talking to you guys about units. In air quality studies, we need to know about concentration of whatever pollutant we're measuring. With the air quality pods provided by the University of Colorado Boulder, we're looking at pollutants such as carbon dioxide, volatile organic compounds, and ozone. These pollutants are gaseous pollutants, and for those measurements of concentration, we want to be thinking of ppm, which is parts per million, or ppb, which is parts per billion. ppm and ppb will be our units of concentration. These units consider a total amount of volume and how much of that total amount of volume is filled up by our pollutant of interest. So let's start by considering 1 million bottles of Coca-Cola. Let's say that at the beginning, these 1 million bottles are all filled up with pure air. Now we take 4 of those bottles and fill them, instead of with pure air, with pure carbon dioxide. Now we have 1 million total bottles of volume, and 4 of those 1 million are filled with pure carbon dioxide. So we have 4 volumes of pure carbon dioxide out of the total 1 million volumes. This would give us a concentration of 4 parts per million concentration of carbon dioxide. So it's very useful to think of concentration units for our carbon dioxide and volatile organic compounds in terms of how much volume out of a larger total volume is taken up by our pollutant. The larger total volume can be 1 million for parts per million or 1 billion for parts per billion. Now let's look at the plotting website that the University of Colorado has provided. We're looking here at a graph of carbon dioxide over time for one of the air quality pods. As you can see on the y-axis, we have plotted currently carbon dioxide electrical signal, which is a voltage equivalent. This is the raw signal you will see from your pod before any calibration is applied to convert voltage into a concentration unit of parts per million, parts per billion. So when you look at this first plot and see electronic signal, voltage equivalent, these are not concentration units. This is strictly just what the carbon dioxide sensor initially reads during your testing. So if we consider this peak, we have a peak at around 7,000 voltage units. This 7,000 value, it does not tell us a concentration value. It only tells us that we have 7,021 voltage units of carbon dioxide at that time. We can't say how much concentration the pod was exposed to at that time. What we can say from plotting the raw signal in voltage units is that at this peak, we have a higher concentration exposed to the pod than later on in time where we only have 835 voltage units. So when using the raw signal, you can only use this to compare the amount of pollutant exposed to the pod. So at the peaks, you have more pollutant exposed to the pod than at the valleys, but you can't say anything about how much concentration the pod was exposed to. Now let's look at plotting carbon dioxide in parts per million. You'll notice that this graph will stay exactly the same in shape. It will just shift either upwards or downwards and have a different unit on our y-axis, which will be in parts per million. As you see, same shape, but our baseline value is at around 6,000 units in parts per million. Now, when we look at our same high peak, we don't have 7,000 voltage units anymore. Now we have 13,090 parts per million, because our y-axis says parts per million, which is in fact our concentration unit. So at our peak, we have around 13,000 parts per million of concentration of carbon dioxide. Again, you see the same shape, so you have a greater amount of concentration of carbon dioxide at the peaks than in the valleys. But what's different about plotting parts per million on your y-axis is that parts per million is our concentration unit. And so by using the carbon dioxide parts per million plotter tool, we can create a plot in units of concentration to say that at 16 hours and 33 minutes on Wednesday, January 11th, we have approximately a concentration of 13,090 parts per million of carbon dioxide exposed to the pod. These aren't exact numbers, they're only approximates for how much concentration the pod has been exposed to, but it is better for talking about the topic of concentration than if we were to just use our normal carbon dioxide plot in using the raw signal voltage equivalence. So remember, when you plot with just where it says CO2, you will see your y-axis says voltage equivalent, which means we are in the raw units. These are just units of voltage. We can't say anything about specific concentration. Versus when we plot CO2 and then in parentheses you see ppm, this is where we get the same shape, but we have on our y-axis ppm, so these plots will be in actual units of concentration in the units of concentration that I explained earlier in this video.